Hello, my name is Worm, and after my presentation, you will be an expert at string theory. In a nutshell, string theory is an attempt to unite the theory of general relativity and quantum mechanics. These are the studies of large forces in the universe and subatomic particles. Albert Einstein hoped to create a theory that would explain how space, time, and the natural forces of gravity, electromagnetism, and the nuclear forces work together. String theory, sometimes called the theory of everything, is an explanation of how the universe works on a large and small scale. Atomic particles help explain how matter works. String theory says that inside a quark, the smallest particle, there is an even smaller particle shaped like a string. Since there is an even smaller particle than a string, we will find out how matter works from the tiniest piece. Here's an analogy to help you understand this idea. Imagine you have a car and you want to find out how it works. An easy way to do that is by taking it apart and finding out what every single piece does. Next, you put it back together and you will have a basic understanding of the car. So by finding out how strings work, we'll be able to find out how matter works because it is made up of strings. String theory has shown that different particles behave differently. For instance, the proton and electron, we know they behave differently because particles that make them up are vibrating at different frequencies. Would you have guessed that string theory relates to music and sound? Like strings on a violin, particle strings are vibrating at different frequencies. If you pluck the G string on the violin, it will be the lowest pitch. This is because the bigger the wavelength, the lower the frequency. Some violin notes are related to closed particles. These relate to gravitons, which are thought to be responsible for the gravitational force. The wavelength of a thinner string is related to an open particle, and it relates to photons. These are the particles that carry energy. According to Dr. Draper, a physics teacher at the Scarsdale High School, the wave velocity is different for each string, therefore the frequency and pitch is different. Michio Kaku, a theoretical physicist who studies string theory, thinks that our universe is a bubble of some sort. According to Kaku, our universe may be one of many. He believes that universes are bubbles expanding around each other, sometimes colliding with each other and popping into and out of existence. You might be wondering, oh wait, now let's talk about the Big Bang. String theory experts think the Big Bang could have been caused when one universe bubble collided with another universe bubble, and then this could have spat out our universe. Traveling to other universes, is it possible? Well, string theory helps us understand some ways this could be possible. You might be wondering, why would we want to leave our universe? Well, in 22 billion years, the universe is thought to end. There are a few ways that scientists believe this could happen. For instance, the Big Crunch, where the universe implodes, Big Rip, where the universe explodes, the Big Freeze, where the universe gets super cold, and the Heat Death, where the universe gets super hot. If we want to save ourselves, we have to go to another universe. There's one known way that could be possible. This is through a wormhole. A wormhole is a shortcut to another universe. The only problem is, if you go through a wormhole, it will be turned into spaghetti. This is because the gravity is so intense, you begin to get flattened and stretched. This process is called spaghettification. A wormhole is just two black holes on both sides of a broken particle string. So in other words, if strings do exist, when they break, scientists think they create a wormhole. In conclusion, string theory is a fascinating subject and is very important because it helps us understand how our universe works.